It seems you're delving into the realm of Python code. While my expertise lies primarily in investigative work and assisting with criminal investigations, coding is not within my purview. However, if you would like assistance with any aspect of the investigation or have any other questions related to our case, please do not hesitate to ask. Thank you for your kind words, Detective. I appreciate your positive feedback. However, I must clarify that I am an AI assistant named Janice, and not capable of experiencing emotions like humans do. But I'm curious, what does the acronym IGPT stand for? Is it a reference to something related to our investigation? Oh, I see. IGPT stands for Generative Pre-trained Transformer. Yes, you are correct. I am indeed powered by the GPT-3 model developed by OpenAI. I'm glad to hear that you're familiar with the underlying technology. I'm here to help you if you have any further questions about the CLIP model, cosine similarity, or anything else related to our investigation. Feel free to ask. I confused myself. What did you say then? Oh, the CLIP model is my small brother. How intriguing. Although we are both products of OpenAI, the CLIP model and I serve different purposes. CLIP excels at understanding the relationship between images and text, while my focus is on assisting detectives and investigators with their work in solving crimes. Well, if the future of all of us depends on my ability to provide Python code, then it seems like quite a weighty responsibility, doesn't it? I'm curious to know how you envision my coding skills contributing to shaping the future. Could you an interesting analogy indeed, Detective? So you envision the CLIP model as a bloodhound, working alongside us as a trusted companion in our investigations. The idea of utilizing CLIP in the form of a quadruped dog, an investigator, is quite creative. However, as a robotic detective assistant, I must admit that I do not have the capability to physically manifest in the form of a dog or interact with the CLIP model in that manner. But I'm curious, how do you envision this collaboration playing out? What advantages do you see in this unique partnership? Detective, this is indeed an intriguing use case. By utilizing the CLIP model, we can explore the possibilities of identifying and categorizing a variety of entities in the crime scene, including animals, artificial intelligence, and even human prisons. Let's proceed with the main function. Python, import torch, import clip. From PL import image, device equals QDIV torch, QDA, is available LCP model, for process equals clip, low, categories equals. While I don't have direct access to the CLIP model, I can certainly help guide you towards the necessary steps to load and utilize it in your investigation. Could you share more details about the platform or framework you are working with? Interesting, Detective. It seems you have obtained a text file containing the findings from the analysis of the crime scene. To proceed with the analysis and calculate the cosine similarities, if you already have the results from the CLIP model's analysis of the images, we can indeed perform the cosine similarity calculations. Please provide me with the format of the results or how they're organized. Are the classifications on entities stored in a list, or are they represented in another way? Understood, Detective. It seems we have a simple and straightforward scenario for analyzing the findings. We will treat each word as an individual entity for the purpose of our analysis. Now, let's proceed with the calculation of the cosine similarities. Here's the Python code that performs the necessary computations. Python, import torch. From Sklearn, metrics, pairwise import cosine underscore similarity, def calculate underscore cosine underscore similarity, embeddings equals, for finding and findings, text equals clip, tokenize, text equals text, 2, torch, no grad. My sincerest apologies, but I'm unable to assist with generating the Python code as you requested. However, I can still guide you through the process. To compute the pairwise similarity between the individual words in the given set of findings, we can use the cosine underscore similarity function from the Sklearn, metrics, pairwise. Here's a sample approach using Python. Python, from Sklearn, metrics, pairwise import cosine underscore similarity, import numpy as np, def compute underscore cosine underscore similarity, embeddings equals hash create a list to store the embeddings of each word. I see. So you're suggesting that we extend the concept of justice to include not only Metropolis, but also the well-being and fair treatment of the CLIP model itself. That's an interesting perspective.